Watobe. Thank you for joining us. It's really nice to have you here, as it is to have all the matrics here with us. And thank you so much to my wonderful TA, Nicole, who without her, none of this would be possible. So thank you so much for everything that you do for us, Nicole. One of the things that Watobe has asked us to do is to give you feedback on the quizzes that are written. So I don't know about your teachers at school, but if I have to mark anything with my class, it's always the first thing that I do. So that's why I thought I would go through this first and foremost. I don't know if most of you had a chance to do this. I do get the scores, but I must be honest with you, I haven't actually had a look at them yet, which is a bit naughty of me. But anyway, as far as the quiz of the 9th of June is concerned, so the first one where you were asked to define a parabola, it meant in terms of like what sort of relational function is it? Anybody want to tell me what you thought it was? Anybody done the quiz and got an answer? Or if you're just looking at ABC, which one would you pick? Okay, so Johannes says C, Kanyisile says C. Quite right. Okay, so it's a many-to-one function. That's it. All right, lovely. Well done, guys. That's good. All right, so that was the correct answer there. Good start. All right. Second question was define an exponential function. All right, so again, I gave you the same options, one to many, one to one, many to one, and Aisha says E. Correct, Aisha. Good job. Well done. Very nice. Okay, E is the correct answer there. One to one. Nice. Okay, now number 3. For the inverse of a parabola to be a function, we must restrict the what of the original domain. Okay, so Lesedi says G, Aisha says G, Johannes says G, Lesedi says G, Kanyasile says G, it must be G. The domain, 100%, guys, quite right. So this is certainly shaping up to be fairly simple so far. All right, I'm glad. Next question, number 4. The exponential function is the inverse of the what function? Okay, so now Johannes, Pumeza said A, Johannes said A, Kanyisile says C. Okay, so the exponential function is the inverse of the logarithmic function. Okay, so Taniko, Thelma, Aisha, Kanyisile, 100%. Okay, good job. The inverse of the quadratic function doesn't actually have a name. We just call it the inverse of the quadratic function. Okay, but yeah, 100%. Okay, so the exponential function is the inverse of the logarithmic function. Good job. Okay, Pumeza, it doesn't matter. Don't worry. Okay, can you see, please, can you explain number 5? Okay, so we use logs to determine the value of the, given the base and the value of the equation. All right, so what I was trying to do here was to get you to understand what you are using logs to solve for. So what are we, when we use logs, what are we solving for? We are solving for the exponent, exactly. We are, exactly. All right, 100%. So that's L, or I know it probably looks like I, but it is an L. Absolutely. Okay, so we are solving for the exponent. So funny enough, that was one of the things that I wanted to talk about this evening. You'll see I've got it written on the page next to us here. But if you learn this, I think it makes your life a lot easier. Okay, so in other words, base, exponent equals number. Okay, does that make sense? Okay, so in other words, for example, 3 to the power of 2 equals 9. Right? Now, when I work with logs, I've got log, base, number equals exponent. All right, so in other words, 2 is equal to base 3. Hang on a second. Oh, that's why. Sorry. Stupid me. So log, sorry guys. Put my brain into gear before I start talking like I always say to the boys. Okay, log base is 3 equals 2. There we go. That's better. Okay, so if you learn that, Kanyisile and everybody else, it'll just help to make your life a lot easier, especially when they ask you to work with the equation of the log function, or if you have to sub things in and then solve for something else, it'll help you with that. Okay, so just bear that in mind going forward. Does that help, Kanyisile? So yeah, the idea is that when we use logs, okay, all right, it makes sense now. Sorry, it maybe wasn't phrased in the best way. I mean, of course, you know, with these quizzes, they're never going to ask you these sorts of questions in exams. That's why we've got to do the exam question. It's just literally testing your knowledge and your understanding. Okay, so the next one was, what is the inverse of y equals 2 to the x? So what did you say here, guys? Indeed. Okay, well done. It is h. Okay, so the log function. Good job. Yes, Lisedi. Yes, Taniko. Yes, Aisha. Good job. Okay, and then last question, question 7. What is the inverse of y equals log 3 to the x? So in this case here, that y, that's your exponent. Okay, 3 is your base, x is your number. Okay, so you're all saying L. Yes, perfect. Good job. Nice. Well done, Buhle. Well done, Naseri. Nice, Aisha. Yes, Valerie. Yes, to Nicole. Okay, good job, everybody. Okay, so that was last week's quiz. Before I move on and get started, do you find going through the quiz helpful? Is this something that you would like to see me do every lesson? And please, could you respond with a yes or no in the chat? So yes, if you do want to see the answers to the quiz, and no if you don't. Cool. Perfect. All right, 100%. And then the last thing I actually want to ask you, since we're kind of on a roll now, that's perfect. What topic would you, or topics would you like me to cover during the holiday period? So we're supposed to be covering things that you've done, that you've maybe struggled with. What would you like me to go over? Probability, okay. Grade 11 probability or grade 12 probability, Aisha? So fundamental counting principle, or like Venn diagrams and functions? Okay. So Spongile, do you mean, so rather than inverse functions, do you mean just like normal parabola, hyperbola? Euclidean geometry, cool. Trig and Euclidean, trig. Yes, can you see? Yes?
Calculus, especially the functions.
Okay, so the graph. Okay, all right, calculus. Okay, so there's a good mixture there. Okay, guys, that gives me an idea of what to plan for you. All right, well, hopefully I can design something that suits everybody's needs. I will certainly do my, yeah, Euclidean geometry is always, and trig, those two are always ones that we get stuck on. No problem. Anyway, thanks for your input. Let's get started on our lesson now. I'm going to zoot over to the side over here. And what I did is I went and I found a whole lot of questions on the logarithmic function, things that have come up in past papers. So these are the sorts of things that they would ask us in exams that we would have to be able to answer. So all of these come from past papers, and you can see here that was out of 8, this was out of 11, this one here is out of 14, it's a little bit more. So that's sort of how many marks we're looking at on inverses. All right, obviously there would be more marks in the paper, so paper 1 on the parabola, the hyperbola, etc., etc. Okay, so that we would definitely need to know, those things as well. Okay, so in question 6, we've been given the graph of f of x equals log 4x. Right now, if you've learned what that is the inverse of, then you know exactly what it is that you're looking at. All right, hopefully. So all that theory hopefully comes flooding back. So in other words, you know that you are looking at the reflection of a certain function over the line y equals x. If they ask you to, which they will more than likely, to write that, the equation of the inverse, then you know exactly what it is that you're going to be writing. And we'll talk about that now. I'm not going to give the answers away just yet. The only information that they've told us is that the point B with coordinates k for x and 2 is a point on f, and that's the only information that's been given to us. So the first thing that they ask us to do is determine the value of k. All right, so instead of me telling you guys what the answers are, I know you might be a little bit shy, but I'd also like you to sort of really engage with the question as well. So I want you to sort of try and tell me what you think the answer is. Please don't worry about making a mistake. Like, I'm not here to judge you, neither is Nicole. We're all just here in the spirit of learning. So if you do get something wrong, it's honestly no big deal. We'll fix it and we'll move on. Okay, all right, so anybody got an idea as to how we would calculate the value of k? Because really it's the how that's important. What do you guys think? You can put it into the chat or you can unmute. What would you do?
Substituting the y value that we have into our function.
Absolutely, absolutely. So where would you put the 2 in place of a variable in the equation? Where would you put the 2?
F of x.
Absolutely. Okay, so they're implying here, all right, that is your y value. That would be your output. So there would be 1 mark, quite right, can you see, if we're subbing in the 2. And now, in order to be able to work out what k is x, isn't it? That's going to be our number. Okay, so now this is why I've written this here. Okay, so that you know what it is that you're looking at. Log base number equals exponent. Okay, so now what they want us to do is they want us to figure out the value of the number. So in other words, the value of k. All right, so now our number, in other words, x, is going to be equal to, x or k is going to be equal to, the number is equal to base to the power of the exponent. So your base is 4 and your exponent is 2. So that means that k would be equal to 16. Does that make sense to everybody? Do you see? I hope you see what I'm trying to get at with these log base number equals exponent and base exponent equals number. I hope that the usefulness of this is now sort of becoming apparent to you. Everybody okay with that? Where did I get the 4? From the equation. All right, so here, up here, was it Spongile who asked me that? Let me just have a look. Spongile, yes. Okay, so Spongile, if you look here, I don't know how easy it is for you to see this. It is a little bit small. They have given you that this is the graph of f of x equals log base 4x. Okay, so that's where that comes from. Okay. All right, so that's the first question. The second question asks us to determine the values of x for which f of x is greater than or equal to -1 or smaller than or equal to 2. so what is this question asking us to do? What does it mean, first of all? Oh, sorry, before we carry on with that. Your marks here would be for subbing in the 2 and for the 16, by the way. Okay. So yeah, what does question 6.2 mean? What do they want us to look at? What information have they given us? How do they expect us to use it? What's going on here? Can anyone explain that simply enough? Shall I take your silence as a resounding no, Matrix? That's fine. All right. So what I'm going to do here is I'm going to draw a straight line. And now, oh no, I don't want that. Now I'm going to draw another kind of straight line. Like so. Right, and I'm going to explain to you now why I'm drawing these straight lines on here. Makusandile, find the x value at y equals -1. Absolutely. Absolutely. Because we know what the x value is at 2, don't we? So in other words, what they've done here is they have given us a range of numbers to work between. So what we are looking at over here, right, this is where y potentially would be equal to -1. And this is very definitely where y is equal to 2. Look, we know that y is equal to 2. So what I've drawn here is the line y equals 2. And over here, what I've drawn is the line y equals 1. So what they are asking us for is for which values of x is y between -1 and 2. So in other words, we need to list all these x numbers from this one over. Oh God, why did that go away? Why does this happen? That is so irritating. Hold on a moment. Are we back? Can you see this?
Not yet, Lee.
Hold on. Stupid thing. It must be when I touch my writing pad in some way. It obviously closes what I'm sharing. I haven't been able to figure out how, but anyway.
But it's back now.
Is it back now? Oh, good. All right. So at this point over here, this is where y would be equal to 1. So we're going to work out what that corresponding x is. At this point over here, that's where y would be equal to 2. So we're going to work out what that corresponding x is. So in other words, between this x over here and that x over there, outputs are greater than or equal to -1, but smaller than or equal to 2. Does that make sense? No problem, Neo. Glad you're with us. So we know the answer to the second part, okay, because we know what the value of x is when y is 2. So x has to be greater than or equal to some value, which we're going to have to discover, or smaller than or equal to. So y is equal to 2 when x or k is equal to 16, right? What we need to do is figure out what number goes in here. So in other words, what is the corresponding input when output is -1? So in other words, what they are asking us to do, again, sorry, 6.2, is they are asking us to calculate the input when the output is -1. So now we're going to say -1 equals log base 4 to the x. Remember, if they want input, we need to solve for x. Okay, and again, these things that I've drawn in blocks up there, this will help you. Okay, so go from the log form into the base exponent form. All right, so hopefully everybody is shouting out and saying, yes, 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 we know how to do this. It means we would have x is equal to 4 to the power of -1. Okay, number equals base to the power of 1. Okay, exponent. So that means, Matrix, that x would be equal to 1 over 4. So that's what's got to go in here. Okay, this is 1/4. All right, so I would guess here, well, we can look at the memo, but I would guess here there would have to be a mark for you working that out, and then there would be an accuracy on that whole thing. You can't have part of it or whatever, it has to be the whole thing. How do you all feel about that? Thumbs up, thumbs down? You feeling good? Cool, thanks Kanisi there. Cool, Michael. Nice, Pumeza. Thank you, Thelma. All right. Cool, Valerie. Okay, so if there's anything that I say that doesn't make sense or whatever, then please do jump in. Lukewarm. Okay, Johannes, we want to get you from lukewarm to boiling hot, okay? Hopefully we'll be able to do that. All right, now 6.3. See, now if you've learned your theory, this is such an easy question to answer. Write down the equation of f to the minus 1, the inverse of f in the form y equals. Okay, so straight away our theory should kick in and we should say we know exactly what this is. What would you guys write? Y equals?
4 to the power of x.
That's it, 4 to the power of x. Beautiful. All right, lovely, good stuff. And now, nice question. For which values of x will x times f minus 1x be smaller than 0? Okay, what does that mean? How do we interpret that question? What are they asking us to do here? Can anybody explain what that means? So with these sorts of questions, matrix, what they're asking you again is they're asking you for a domain between which values of x is this happening, or at which value of x is this happening, or is it happening when x is smaller than a certain number, or is it happening when x is bigger than a certain number? That's what they're asking you. And most students can't answer these sorts of questions because they don't really understand what it means. And when you understand what they're actually asking you, it really is very, very straightforward. Over here, the x represents input. Inputs are numbers, okay? They're just numbers. So x represents a number, either a positive number or a negative number. Now, in this case, if we have a look at this particular function, okay, x has to be greater than 0 for all values of x, okay? Because remember, our y-axis is our asymptote, so we can't get negative x values. So as far as x is concerned, x is always going to be a positive number. The dot means multiply. And this is their way, or our mathematical way, of being able to write outputs on the inverse. So we're talking about input times output. That's really what it means. Okay, so I'll write it over here. X times f means input times output on the inverse. Okay, so if we now go back to our diagram, let me just get rid of all of the stuff that I've drawn on it. Okay, we've said that input always has to be positive. Why? Because we've drawn this graph, or this graph has been drawn, should I say, to the right of the y-axis. So every value of x is positive. Okay, so we're only looking where x is positive. Then as far as this is concerned, in order for us to get an answer that is smaller than 0 means negative. So if I say a is smaller than 0, I'm saying a is negative, for example. Okay, so if I multiply two numbers together and I want a negative answer, one of them has to be positive, the other one has to be negative, doesn't it? Okay, so the only way I can get a negative answer is if I have a positive times a negative. So in this case, for this particular function, x is always positive. Now we have to look at the value or values of x for which output is going to be negative. Now remember, sorry, hang on a second, it was the inverse. Nicole, sorry. It's not this function, it's the inverse function. So, my mistake. Hang on, let's just sketch it quickly. All right, so they're asking us about that graph. Sorry, guys. Just goes to show what happens when you don't read the questions properly. Okay, so they are asking us, beg your pardon, it still means it's input. What I wrote there is correct. So it's input times output on the inverse. And sorry, in this particular case, that was our inverse over there. All right, so it's the graph that I have now drawn here in pink. The inverse is 4 to the x. Okay, so input times output has to be negative, right? So if we have a look here, the inverse is now true, all right? Y is always positive. So output is going to be positive for all values of x. Well, if we want a negative answer overall, then we have to consider those values of x that are negative, all right? So x is going to change sign from this point onwards, all right? So we can only consider those values of x that lie to the left of the y-axis, because then a negative input times a positive output will give us this negative that we want overall. Does that make sense to you? So when they say to us, for which values of x is this going to happen? It's going to happen when x is smaller than 0. Does that make sense? You sure, guys? Okay, all right, so Aisha, I will try and explain it again one more time. Fine, Pumeza, not a problem. I know that these are conceptually very difficult. Where do the 2 marks come from? You know what we'll do, Lissetti? We'll look at the memo and then I'll tell you. Normally it's an accuracy on whatever's been written there, 2 accuracy marks. Okay, but we'll look at the memo. I did stick it on the side over here. Okay. So when they, let me just write this off as well. So what they are writing here is this x over here means your inputs. These are the values on your x-axis, all right? The dot means times, and f minus 1x is a way of writing what they mean is the outputs of the inverse. Okay, so remember, in this case, our original function is a logarithmic function. Our inverse is the exponential function. So they are saying input times output, but they're not talking about the outputs on f. They're talking about the outputs on the inverse, on the exponential function. Okay, so the outputs on the exponential function. Okay, so in other words, the function that they asked us to find the equation of in question 6.3. That is the graph that they are basing question 6.4 on. So they're asking you a question about a graph that's not even drawn. Okay, and that's why I drew it in there for you so that you could see it. So by now, we all know what y equals 4 to the x looks like, isn't it? It's an increasing function, and it is the reflection of f over the line y equals x. So I've drawn it here for you in pink. So now if we go and we have a look at our pink function, right? What line is the horizontal asymptote? The x-axis, isn't it? That's our horizontal asymptote. So is it possible for y to be 0 or negative? No. Y cannot be 0, y cannot be negative. So now what we've got is we've got a situation where we are multiplying a number by another number, and what we want is a negative outcome. But this number over here, this output, is always positive, okay, because y is positive for all values of x. Okay, it's never ever negative and it's never ever 0. So the only way we can get a negative outcome when we multiply a positive number with something else is if we're multiplying it by a negative. So what that means is that, so here's the y, that's the, over there, here's the x. So that means because output is always positive, we can only look where input is negative. Okay, so now they've said to us, for which values of x will this happen? So now we go and look at the graph and we say to ourselves, okay, well, at this point over here, this is where x is equal to 0. If we move to the left of this line, we've got negative inputs and positive outputs. So a negative times a positive will give us a negative. Negative times a positive will give us a negative. Right, so it is when x is a number that is smaller than 0 to the left of the y-axis, we are going to see this happening. Okay, do you see that, Pumeza? Okay. Okay, so where x is smaller than 0. Okay, the sign of the input is negative, the sign of the output is positive, giving us a negative overall. Okay, so that's what they love to do in this section. They love to give you, and this is what I was trying to, I wanted to tell you, but I don't want to overwhelm you either. This is the sort of thing that they ask you about these logarithmic and exponential functions, that they ask you questions about a graph that's not even drawn. So, you know, that takes some sort of serious understanding to be able to answer that. But anyway, hopefully you're feeling better. Okay, so now let's just go and have a look at the memo. Just for, where is it? There we go. Okay, so yeah, like I said to you, it would be 2 accuracy marks on the answer only. Okay, that I'm sure you've seen that at school as well. Okay, so yeah, so it was the substitution of the k and the 2. Yeah, it's exactly what we did. All right, so now you can see where the marks were awarded. And of course, if you want to write your answer as x is smaller than 0, or if you want to write it using interval notation with the brackets, you're more than welcome. I, for one, try and stay away from interval notation, not for myself, but just because I think it's a little bit more difficult to understand. Okay, so let's go on. Let's go and look at the next question. This is a little bit more marks than the previous one. So now we've been given an exponential function. It is the graph g of x equals 1/2 to the x. So now if you want to access this question, you immediately need to know exactly what that graph looks like. So if you want to, you could even draw a little picture of it for yourself so that you know exactly what it is that you're dealing with. So straight away, this is what I would do. That's what I've got. That's what I'm dealing with. Okay, so g of x equals 1/2 to the x. It's a decreasing function. It is the reflection of y equals 2 to the x over the y-axis. All right, so there's your y-axis, there's your x-axis. That's what they're talking about. Write down the range of g. Okay, so that's a pretty easy question. The range in this case, what would you guys say? Remember, the x-axis is the asymptote, the horizontal asymptote. There we go. Good, Johannes. Okay, perfect. Y is greater than 0, 100%. Okay, so the graph never touches the x-axis and it certainly never goes below it either. All right, good job, nice. Now they jump straight into determine the equation of g minus 1 in the form y equals. And again, if you've studied this, you could just write your answer down. Okay, you're going to get full marks for writing down your answer. Anybody want to tell me what you think it should be? You all, you know what, you guys are just tired, aren't you? There we go. Johannes, now you see, now you told us that you were lukewarm, and now that's absolute nonsense because you're not lukewarm. Look at that. You've answered both of these questions. Awesome. Okay. Yes, guys. Okay. Yes, all of you are correct. Okay. Good job. Okay. So log the base is 1/2, and x is the number. Okay. There are other ways in which you can write that, but that's the way in which we're going to write it. Okay, perfect. Good stuff. 4.3, is it a function? Justify your answer. Okay, so now this goes back, exactly, Nicole. Now this goes back to our first lesson. It's straightforward theory from that, 2 marks. Is it a function? Yes, Boutle. Why? Why is it a function?
For every x in the domain, there's only one y in the range.
Absolutely, absolutely. So it's a one-to-one function. Absolutely. So you could say, yes, it's a one-to-one function. What else could we say? I think it would be okay for us to even say that it passes the vertical ruler test. Okay, so yes, it's a one-to-one function. It passes the vertical ruler test. Okay, good job. That was really nice. Well done. So we should get 2 marks for that. We can look at the memo afterwards as well. All right, now look at this, guys. They haven't, the graph is not sketched, right? And now they're asking us questions about it. That's also, it's really, really difficult because now we have to imagine what it is that they're asking us questions about, which I think is why it's nice to have it sketched here on the side. So now they've told us we have this point M, A and 2, and it lies on the inverse. Okay, so now you have to say to yourselves, okay, now we're talking about the inverse of this particular function. What is it going to look like? Shall I just draw a quick picture of it here for myself so that I know what I'm dealing with? Now, this is the one that I always struggle to draw on this pad. Ugh, Yira. Sorry, guys. Oh, no. There we go. Okay, it's not the best diagram, but there we go. Okay, so there's our line y equals x. There's g, and here is the inverse. Okay, the reflection of g over the line y equals x. All right, so now they're telling us that the point M, A and positive 2 lies on that. They want us to calculate the value of A. All right, so how are we going to do that? What are they giving us? It's actually very similar to a question that we've already done up there. What does 2 represent?
Y.
It absolutely, Cassandra, it does. Yes, guys. Yes, Kamisile. Yes, it represents the Y. So if we now want to work out what A, the input is, again, can you see we're using that same thing that we were doing up here? Okay, over here. So in other words, what we've got is log base A is equal to a number. In this case, the number is 2. So that means we now need to solve for our input, A. So A equals base. Hang on. No, that is correct. Hang on, sorry, I'm just thinking carefully here. I'm not sure of what I've. Oh yes, no, sorry, I'm just being stupid. Okay, all right. So 1 over 2 to the power of 2. Sorry, guys, I just want to think through carefully. All right, so that would be equal to 1 over 4, like so. All right, yes, absolutely, I quite agree. All right, good job. Now they say to us, M prime, the image of M lies on G. Write down the coordinates of M prime. It's actually such an easy question. All right. And then you can see it's only out of 1 mark. All right. So what are they asking us for here? They're asking us for a point that is mirrored on the inverse. All right, so in other words, we've got this point, 1/4 and 4, wherever that is, that lies on G. So I guess it would be somewhere kind of down here or maybe closer. What we've done is that we've said that its mirror image lies. Okay, so it lies over the line y equals x. Does that make sense to you? So that point has been reflected over the line y equals x. So if it's been reflected over the line y equals exactly, Johannes, you see, you were telling us that you are only lukewarm. You're talking nonsense. You are definitely super boiling hot. Swap the two around. Quite right, because when we reflect over the line y equals x, x is y and y is x. All right, so that means that the coordinates of M prime have to be 2 and y is 1/4. Okay, very nice, good job. All right, and now for the last question. Is everybody okay so far? I'll be happy, making sense, all good. Okay, Spunkila. Cool. Thanks, Pumeza. Thanks, Butchepo. So now, perfect, guys. They go and ask us one of these dreaded questions. So if h of x equals g of x plus 3 plus 2, write down the coordinates of the image of M on H. Ooh, okay. So in other words, sorry, I'm just readjusting myself here. So in other words, they are asking us to write down these new coordinates. So in other words, we're taking this point over here, or this function that this lies on, and we are transforming it in a certain way. All right, so that's what this is. This is a transformation of G. What is the transformation that's taking place? We have to understand that in order to understand how our coordinates are going to change. What is the transformation that's taking place? Is it a reflection? Is it a translation? What are they asking us to do?
Ma'am,
Yes, Cassandra.
I was saying that we are going to move 3 units to the left and 2 units up.
Absolutely. Absolutely. All right, no, that's really good. Well done. So this is confusing. This always confuses grade 11s and it confuses grade 12s as well, right? So here they are providing you with an instruction. They are telling you to add 3 to x. By telling you to add 3 to x, they mean that if we subbed in +3, it would shift the graph to the left-hand side. So this is instruction to shift left by 3. This over here is an instruction to shift up by 2. So in other words, what they really want us to do to these coordinates of m is they want us to start at 2. I'll put the 2 in pink, and they want us to take away 3. And again, we're starting at a quarter, and they want us to add 2. Does that make sense to everybody? So the coordinates at m prime are going to be, on h of x, are going to be -1, and 2 plus a quarter would be 9/4, like so. Yes. How does that feel, guys? Does that make sense? Yes, Paul, go for it.
Ma'am, I'm a bit confused of the x plus 3 because it says +3. So does it
Yes.
mean it goes to the positive side of the x-axis or the negative side? Because I thought that if you minus it, it goes to the negative side.
Absolutely. So now this is one of the things about maths functions that confuses so many students when they go into grade 11 in matric, is this whole idea about shifting left or right. So in the way that this has been written, okay, this is an instruction to you. So they're asking you to add 3 to x and 2 to y. All right. By asking you to add 3 to x, you shift the graph further to the left-hand side. So I don't know if you remember, like it's the same with the parabola. So if we've got the graph of, let's say y equals x plus 2 squared plus 1. That's a parabola, right? And they tell us to transform this. Now it would be f, and then here they say to us x plus 3 plus 2. They are telling us to add 3 to this 2. Remember, this graph has already been shifted 2 units to the left. Its axis of symmetry is the line y equals -2. So if I add 3 in here, I'm moving it not just 2 places to the left, but a further 3 places in the same direction. So that's why your new axis of symmetry would be the line x equals -5. Okay, so when it's plus inside here, the graph has been shifted to the left. When it's minus inside here, the graph has been shifted to the right. Does that make sense? And then obviously the +2 on the end here, we would add that to the y. Okay, but this is something that is particularly difficult, and it's something that a lot of students struggle with. Bochepo, are you a little bit happier?
Yes, ma'am.
Okay, all right. Good stuff. Okay, so let's just go and have a look at the memo where the marks were allocated here. Let's just see, they said. Okay, so we said the same thing, that y was greater than 0, 1 mark. Oh, there we go. That was what I was trying to say. There would be a number of different ways in which you could write this. We only do it like that, but you could write it in any of those forms if you wanted to. Yes, for every x value, there's a unique y value. That's what, who said that? Was it Marco Sandile? I think that was your answer. Or yes, it's a one-to-one function, or it passes the vertical line test. Lots of things that we could have said there. So yeah, subbing in again, A on the answer. Yeah. Okay, so there we go, guys. All right, so that's what the marks were awarded for. Okay, so we've got 10 minutes left, which means just scooch that over so that we are not distracted. Okay, so let's have a look at this. I don't know if we'll be able to finish all of this by the time that our lesson is over, but I will do my very best. Okay, so now they've given us a combination of two. Right, so that's why I put the first one at the front, because it was the easiest, and then the second one, and then this one, which is obviously a combination of two. Now look at what they've done here, guys. They have combined what sort of graph is G, Matrix? What's this? What sort of function is that? It's a?
Hyperbola.
It is a hyperbola, quite right. So they have combined, it is Orotile, they have combined a hyperbola with a logarithmic function. Isn't that nasty? Hey? So those are the two that they have put together in this case, a hyperbola and a log function. Now they give us some information. So y equals -1 is the horizontal asymptote of G, right? B is the x-intercept of F, fine. A, T and 1 is a point of intersection between F and G. The vertical asymptote of G intersects the x-axis at E and the horizontal asymptote at D. OB equals BE. Okay, so that's all the information that they are telling us over here. All right, so there's the point A where they intersect. BE and ED over there. D is what I like to refer to as the new origin. So in other words, it is now the center for this particular function instead of the origin anymore, because this graph has been shifted to the right and it has been shifted down. Okay, and then our log function has to be, so what I'm going to do, let's highlight the exponential function. Well, let's do the log function in blue because that's the color that we used up at the top. So there's your log function. Okay, I don't know if this helps you, but I believe that color helps. So I like to highlight things. Okay, and then here is our hyperbola. All right. So if they have told us that the horizontal asymptote of the hyperbola is the line y equals -1, then essentially they have told us the value of what? P or Q, Matrix? So if they have told us
Q.
exactly, Boutle, quite right. Okay, so in other words, this over here, this means that Q is equal to -1. All right, so maybe they're going to ask us to work out the value of P. Okay, oh no, not yet. All right, so write down the range of G is the first question. Okay, so the range of G. Okay, so that's the pink one, guys. What is its range? How would you write the range of a hyperbola? Can anybody tell me? You see, the problem is, Johannes, is it's not like an exponential function. If you look at what's happening with the pink lines, okay, there's one coming down from positive infinity and there's one coming up from negative infinity. And both of them approach the asymptote. And then as they get to the asymptote, because they can't reach the asymptote, they start to curve off like this. Yeah, no, y can be 0. Absolutely, because look, it's cutting the x-axis, isn't it? So y can be 0. That's not the problem in this case. In this case, the asymptote is at -1, so y can't be -1. So what we would write here, and you've got to write both of these, okay, you've got to write that y is an element of the real numbers. And it is that y may not equal -1. Okay. All right, Boyd Sheppel. Then they ask us to determine the equation of G. Okay, so now they've asked the question. So we know that the value of Q is equal to -1. So in other words, what we've got here is we've got the graph G of X equals 2 over X plus P minus 1. So if they want the equation, then what they want us to do is determine that value of P. So how are we going to do that? How are we going to work out what P is equal to? Any ideas? It's in the information that's been given to us. So if you go back and you read the information carefully, I'm dropping some hints here. So they've told us that OB equals BE. And they've given us the coordinates of B. They've told us that B is 1. So if OB equals BE, then at E, X must be equal to? What do you think, Matrix? Unfortunately not Boucher. At B, X is equal to 1. So OB equals BE. That's it, Johannes. Absolutely. Good. Yes, there we go. Is equal to 2. Right. So now, if I did this, am I correct? Hang on a second. Don't write this down. Well, there's a hint. Is that right? What do you think, Matrix? Am I correct in what I've written? No. What's wrong with it, Johannes? Exactly. Okay, so this needs to be a negative. Okay, because the graph has been shifted 2 units to the right. Okay, Boyd Sheppel, the graph has been shifted 2 units to the right, and that's why I have to have a negative inside there. Okay. Okay, calculate the value of T. So now that we have got that equation, I suppose we could do that. Because T lies on both functions, we could either use the log function to get it, or we could use the hyperbola to get it. It would be completely up to you how you would want to do that. So at T, X is equal to 1. So we've seen how we would do that a few times this evening with the log function. So let's just do it with the hyperbola. So we would say that 1 equals 2 over X minus 2 minus 1. Now, I don't know about you guys, but what I like to do with this is I like to cross multiply. So I'm going to take this minus 1 on the right over to the left. I'm going to write that as 2 equals X over 2. And now I'm going to cross multiply. So that's going to leave me with 2X minus 4 is equal to 2. So that means that 2X is going to be equal to 6, which means that X is going to be equal to 3. So therefore, T, in my opinion, is equal to 3. Okay. Everybody happy? 5.4, they now want us to write down the equation of f minus 1, the inverse of f, in the form y equals. So there's our graph f. It is a log function. So it is the graph f of x f of x equals log base 3 to the x. So that means that in the form y equals, it would be the graph of y equals, and hopefully you're all shouting out y equals 3 to the x. Okay, I'm going to try and squeeze this in before we go so that we finish on time. For which values of x will the inverse be smaller than 3? Okay, so in other words, this over here, that is 3 to the x, isn't it? So for which values of x is this graph going to be smaller than 3? So where will 3 to the x be smaller than 3? So now that I've equated my bases, I can say where x would be smaller than 1 with my exponents. All right, so I imagine there would be a mark for subbing in, and then another mark for the answer. All right, last question at 6 o'clock, guys. Determine the point of intersection of the graphs of f and the axis of symmetry of g that has a negative gradient. Now, again, this is where your studying is so important, right? So the graph of g that has an axis of symmetry with a negative gradient, it would be the line, this is what I always teach my grade 11s, it's the line y equals negative x plus k. K represents its y-intercept. Its gradient is always -1. The axis of symmetry with a positive gradient, its gradient is always +1. The gradient doesn't change. But this line goes through your new origin. So now you know what the coordinates at D are. We've already worked that out, or we've used that to, well, we haven't worked it out, but I mean, we know that at E, x was equal to 2, and because they're in the same vertical line, that means that D has to be 2 as well. So that has to be the point 2 and -1. So that's your x, that's your y. So now you just sub in. Okay, so -1 equals -2 plus k. So that means that k has to be equal to add 2, and that would be 1. So this is the line y equals -x plus 1. They're asking us to determine the point of intersection of the graph of f, okay, and the axis of symmetry of g that has a negative gradient. Okay, so now if we consider the line y equals -x plus 1, so it's the axis of symmetry with a negative gradient, it would basically look like this. Let me try and draw it for you. Let me draw it in orange. There we go. So it would look something like that, okay, in orange. And yeah, that's what I thought as well. If we look here, we can see that its x-intercept is going to be the same as b. So for our x-intercept, remember we would let y be equal to 0. So 0 is equal to -x plus 1. Take the x over to the other side. So it would be where x is equal to 1. So that means that the point of intersection has to be b, which is also f's x-intercept. So they share the same x-intercept. Okay, so sorry, it would have been all of that working over here. So the point of intersection where this is going to happen will be b. Okay. Sorry, I've tried to do that as quickly as I can. I'm sorry that we're over. Any quick questions? Okay, Johannes, no problem. Take care. See you next week. Oh, yes, sure, Johannes. What I'll do, it's a pleasure, Cassandra. What I'll do is let me just scooch over here. There's the memo. Okay. So just make it a little bigger so you can see it. Sorry, let me just make it a little bit bigger as well. Okay, so there you go. There's the memo. All right. I think I got everything right. I hope so anyway. Okay. So yeah, if you want to come and watch the video again, you've got it. All right. Bye, Neo. Bye, Jared.